this is really not a competition. We are not trying to, compete them here. These are two great products of Microsoft for different kind of situations. And I'm hoping this presentation is going to actually help you for your upcoming projects. Whenever you need to make a decision, should I go with SQL Server? Should I go with another NoSQL database? Hopefully, this presentation is going to help you with that question if you will have. So first, as you can see, we have a couple of numbers here in the first slide. And I'm sure this is a DBA group, so you probably know what these are. Those are actually the ages of each database. So SQL Server has been out there for a long time. There is a big community out there. So if you have a question, usually you should be able to kind of find an answer online with, everybody's trying to, share the knowledge, and it's pretty easy to, I guess, find answers for SQL Server. Azure Cosmos DB, well, in early years, we used to say that Azure Cosmos DB is a, new database. But as you can see, it's getting old, just like me, right? So it's getting older. So it's 8 years old this year, and it has been out there for some time. So when it comes to the NoSQL, Azure Cosmos DB, has some experience because most of the actually Azure services and products is really depending on Cosmos DB. And they're using, for most of the services as the NoSQL database. So they have actually a lot of experience, especially when it comes to the cloud. Before we go and start to, I guess, go in details or, technical details, let me talk about myself a little bit. My name is Hasan Savran. I have my own company, Savran Web Consulting. Mostly I do consulting on Azure Cosmos DB. But rather than that, I have a full-time job. I work for the Progressive Insurance. I'm the business intelligence manager there. And rather than that, I'm a data platform MVP. This is my, I believe, 7th year, and I'm very happy and proud to be the part of the program. I am currently located in Cleveland. And if you have any kind of experience with Azure Cosmos DB, or if you are trying to learn, please try my VS Code extension. I actually developed that extension mostly for the community. It is free. So as you know, SQL Server actually has SSMS, which is a great tool to kind of run the queries and, do all kind of stuff. So Azure Cosmos DB, most of the stuff is on browser. So I was not really a fan of that. So I actually created on VS Code extension. So you can actually connect the Azure Cosmos DB from your computer and run the queries, and it has some good features out there. You can check it out. There are some videos out there about how to use it, but you can use it. It's free, and hopefully there's going to be some update coming up for that soon. Rather than that, if you have any questions about any kind of content here you're going to see, you can follow me in any of those social media. I will be more than happy to answer any of your questions later too, if you will have. Now, let's start with the presentation. Let's actually start to talk about overall what is SQL Server is. SQL Server is a centralized database. In the centralized database, we have clients, and clients are trying to pull or push the data. The last thing clients worry about for a central database is where the actual database is. We have only one database, and if you have the connection string, we know where data is. It's not client's problem to pull the data from the database. It's database's problem to find the best way to pull the data, do any kind of aggregation, any kind of sorting. You can do all those things in one central place, and that is great. The access is easier. You can easily coordinate the data, but this design, unfortunately, can be easily bottleneck, because if you have many clients trying to pull a lot of data in the same time, well, we have limits, right? At the end, you have a server here, and server is going to have a limit for CPU, for memory, for resources. So it cannot do all those things together sometimes in the same time. So when it comes to the scaling, you might have issues. You can always, increase the CPU, increase the memory, increase the resources, but at the end, you are going to get some type of level out there, and it's not going to be worth it to kind of add anymore because it's going to be just too expensive. So that's only kind of, I guess, like the biggest problems with the centralized databases. Azure Cosmos DB works a little bit different than that. In Azure Cosmos DB, well, it's not really centralized anymore, depending how much storage or how much CPU power you're going to need from the database. You might end up with 2, 5, 10,000, 2,000 databases. And depending on your needs, all of those are going to be available for you to pull data. Well, the first thing you need to realize with this one is, the data is distributed. So that doesn't mean that we have the same data in every database engine we have out there. So if we are, for example, saving the orders in Azure Cosmos DB, some of your orders is going to be in the left side, some of them is going to be in the right side, some of them is going to be in the center. So now the clients kind of needs to help the Azure Cosmos DB a little bit here, because our data is distributed, and they kind of need to give some kind of tip, like where actually the data is. Because if you don't, that means that whatever query you are going to run, you need to run it in every database engine, which will be very expensive to complete. That is actually one of the main reasons people think that Azure Cosmos DB is expensive. It's mostly because of that. If you don't use that partition key, which kind of determines which database engine actually has the data, Azure Cosmos DB is going to be expensive because, well, you need to run that query in many database engines, and you are just using too much resources, which you don't really have to. For example, let's say we have this select statement here. So it says that, select all from orders. C is the orders here. And we are looking for the product ID 10, right? So if you pick the product ID as your partition key, well, Azure Cosmos DB is going to know exactly which database server has the data. For that case, everything is going to work great. So that product ID actually really kind of works here, like, whenever you kind of go to a parking lot and you forget where your car is, it's overwhelming. There's all over the place cars and you have no idea. It just works like that remote, where you click on it and, well, you know exactly where the car is. So it kind of has the same idea. You have a lot of database engines working for you. And by passing the correct partition key, you are really, telling Azure Cosmos DB where the data is you are looking for. So you can run that query only in one database engine or then one database server, rather than, you are doing a cross partitioning all the time. So let's actually continue with partitioning, and let's look at the SQL Server, how actually it works. So in partitioning and SQL Server, usually we do the SQL Server partitioning when the indexes cannot actually handle the size of the table anymore. So we might have like a huge table and a bunch of probably indexes on it, but because the table is getting larger and larger, the I/O seek time is getting longer. So we don't really do that much. But the only thing we really can do is we kind of need to divide that table in small tables, so the I/O seek time can be lower. We do that by the partitioning, and the schema stays same. The user still, see only one table. It's the same database. The data is fewer to scan because, as you can see in this case, we put the data the orders too. So we put all the orders for 2010. We put under the a smaller table which has only orders from 2010, 2011, 2012. This works great as long as you have the partition key in your query. So it kind of is the same idea in the SQL Server. As long as you say that I want to look at the order, I don't know, 1000 and the year is 2010, the data should come very quickly, and everything will work very fast because we don't have to kind of scan the whole big table anymore. We just need to scan a small table. Same idea. In SQL Server, all this happens in the file system. In Cosmos DB, when the partitioning is happening, that actually happens in the database level. So that's, I guess, the biggest difference between two. So if you look at the Azure Cosmos DB here, how it actually works is, well, Azure Cosmos DB almost work just like a restaurant. You open a restaurant, right? Well, you have a limit of the restaurant. You might have, maybe 200 people. You might have X amount of waiters because, well, that's what it takes. It cannot have, more than that. If you hit the limit, what can you do? Well, in SQL Server, what you try to do is maybe you are going to try to add another floor on top of that, or you are trying to make your, a restaurant a little bit bigger, but that costs you a lot of money. In Cosmos DB, it works like franchising. So you open this restaurant, you hit the limit. What do you do next? You want to open another one, maybe in the next street out there. Same idea, same menu, same thing. It's just like that's how you actually handle when you need to scale for the Azure Cosmos DB. That's called scale horizontally rather than scale up. So if we go and look at a little bit more technical, then this, I guess, is what's really happening here is every time you have a database server for the Cosmos DB, you really have a replica set. So in one Cosmos DB database, you have 4 computers. And the first one is the leader. Leader is responsible for all the updates, insert, deletes, anything needs to change. All that needs to go to the leader first. From there, leader syncs up with the other 3 followers in the replica set. So that kind of explains you why Azure Cosmos DB is pretty fast, because, well, if you are the web application, you try to pull data, potentially you have 4 places to pull data, depending what consistency level you actually pick. So there are 2 numbers you really need to know here. So this one is called in Azure Cosmos DB a physical partition. You really cannot change anything here. Everything is maintained by Cosmos DB, but there are 2 numbers that you really should know by heart. The first one is the limit of storage. 50 gig is the limit of storage per physical partition, which means if you're going to get close to the 50 gig, that means that we are going to actually have another physical partition gets triggered, and Cosmos DB is going to try to balance the data between 2 servers. And that's how, the data or your servers are going to get larger and larger. 10,000 request units per second is the second number that you should know. That is really the horsepower of this database engine. That's what it can deliver to you per second. If you need more than that, that will trigger actually another physical partition for you. And that's how actually Cosmos DB grows. As you can see, one of these actually says here the forwarder. One of those followers turn into the forwarder if you are in different regions. So for example, you have an east and west structures. So in that case, the forwarders actually what it does is when data comes as an insert data from the leader syncs to the forwarder, and the forwarder job is actually take that data and give it back to the other leader in the different region. That's how the data gets syncs up in the backend with the different regions in the Cosmos DB. As I said before, there's really nothing you can change. Everything maintained by Cosmos DB. But there's one thing that you can do under that, which is the logical partition. Logical partition is the way that you actually organize your data in Cosmos DB. And each logical partition, you declare that by a partition key. One of the tricky things actually in Cosmos DB, you kind of need to know what partition key before you actually create your container. So you kind of need to figure out your data model and be sure that whatever you are picking partition key is unique, and it's not going to actually hit that limit, which is the 20 gig limit of data. So, for example, if we are saving orders, there are a couple of things you can do with the partition key, right? So there's going to be all kind of options as options in the fields. You might have, for example, order ID. You might have a customer ID. You might have state, or you might have the order date. If we are in SQL Server, we usually mostly use some kind of data to organize the data. That is the last thing you want to do in Cosmos DB. You want to be sure that there's going to be the numbers are going to be very unique. And in that case, depending what you are trying to do, most of the time I will go by the customer ID, because if you're going to use the customer ID, how many orders a customer ID can have. So you probably shouldn't hit that 20 gig limit if you pick the customer ID. You can pick the order ID. That will make everything very unique. So all the writes will be very fast. But the problem is whenever you are trying to pull the data, you might not have the order ID all the time. So that will cause cross-partitioning. So whenever you pick the logical partition, just really think about it and be sure that you select the right one, because that's one of the most important decisions you make in Azure Cosmos DB, and probably it's gonna, you are gonna figure out how much actually it's gonna cost. Really, most of the time depends on the if you pick the right partition key or not. So if we go in details a little bit more with the, I guess, partitioning. So as you can see, we have a container here as an example, and it looks like our partition key is customer ID. So in this case, looks like we have 4 physical partitions, which means that we have 5 different servers here, and each of them has a replica set in it. So, and each of them has, group of files or the group of customers, because partition key is the customer ID. As you can see, those blues are representing that. So if you look at the details of every physical partition, you will see a hash number. It will be a minimum hash and maximum hash for each the server. So what actually happens here is when we try to insert a new, for example, order here, what is going to actually Cosmos DB going to do is it's going to go and hash the partition key. Or in this case, let's say John1234 is the username for the customer ID. We are going to hash that John1234, and we are going to find some kind of hash. Then we are going to look at all the hash ranges here, and Cosmos DB is going to take this data and put into the correct the server, whichever the actually hash is in it. So that's how we control which database engine or database server is going to have which data. This is inserting the data. Selecting the data works exactly the same. If we are going to select the same thing, let's say I want to get all the orders for customer ID John1234. If I use customer ID in my where filter, Cosmos DB is going to find that and actually is going to hash that partition key, and it's going to figure out which database server actually has the data. And it's going to send that select statement to only one server here, because we know we use the partition key in the where clause, and we know exactly where the data is. If your select statement is going to not have the customer ID, well, let's say that maybe you are looking for all the orders for a product. Well, in that case, unfortunately, there's nothing to hash here. Then this query is going to go in, 4 partitions, and it's going to cost you much more because of that. Next is query plans. In SQL Server, let's say we have the select statement. The first thing SQL Server is going to do whenever there's a, it needs to make any kind of query plan is first it's going to look at your syntax, figure out if there's any problems with it. Then it's going to go and map the columns and be sure that all the tables and columns and all the objects you have in the select statement exist in the SQL Server. Then it's going to go into the query optimization. Query optimization is probably one of the most powerful part of the SQL Server. And it's going to try to actually find this data in different ways by looking at the indexes, looking at the statistics, size of the tables, and it's going to create many query plans. And then it's going to go back and try to figure out which plan is the cheapest way to actually get the data. It's going to select that data, or it's going to select that query plan, execute the plan, and cache the plan. So if this select statement comes back again later, it doesn't have to do all that work again. It can just run the cached plan. So that's how, I guess, we end up with the select statement becomes some kind of results in SQL Server. If we look at the Cosmos DB, it's similar. There are some differences here at the end. It's a database, right? So it's the same kind of query here. We are looking for, let's say orders and the parent ID of the, whatever is 11. So this is the query. The first thing we are going to do is the parse and bind. So this parse and bind is going to be very low here because, well, there's no schema in Azure Cosmos DB. So we don't really need to do validation that much. If property is not there, if the column is not there, well, it's not there. That's not a big issue in Cosmos DB. The biggest thing it's going to actually check here is it's going to look at your SDKs, your applications, how many, like you actually created. If you create it as a 64-bit, that means that we can actually generate the query plan locally. We don't have to go to Cosmos DB to create the plan, which is going to actually save you one request before we start. So just be sure that whatever application you are running and calling the Cosmos DB from, just be sure that you develop that in 64-bit, not like any CPU or 32-bit. Just be sure that you pick the 64-bit because there is a DLL file named service interrupt DLL, and that exists only for the 64-bit, and that will actually save you one request for every query. So from that point, we are going to go to the query optimization. Really, again, there's going to be not that much going on here. The first thing is going to decide if we have to do the query plan locally or not. Then we are going to look at if the partition key is in the filter. Well, if it is, that's good news. That means that we can actually hash that. Well, which SDK is going to do that? We are not going to do that, but it's going to happen in the backend. It's going to actually call the only one server here rather than doing a cross partition. Next one, which is a little bit kind of interesting here. So if this is only one server and we are going to get the data back, that's correct. That's all the data we get. But if this is a cross partition query, then we might have some issues here. Like, for example, you might have like an order by, or you might have any kind of aggregation, find the minimum, maximum count. All of those aggregations actually has to happen in SDK. If you really think about it, the database, we don't have one database engine, we have many of them, and each of the server doesn't know what other data the other one has. So there's no way we can really do any kind of order by. We cannot figure out which one is minimum, which one is maximum. So all that data has to come to the SDK, and SDK is the one which is going to do most of the aggregation. Actually, you do the queries. That's one of the reasons wherever actually that application is running, you should have some good resources for that, because it's not just like getting the data and rendering the data. Depending what your select statement looks like, it might actually need to do a lot of like merging data and doing sorting and group by and all kind of things out there. Right. Next one is data models. So in SQL Server, it's a relational database, but you can still save JSON objects. You can query JSON objects. XML has been out there for some time. Graph database tables has been out there, I believe, 2017. So, your data has to be, I guess, relational in SQL Server. There are different ways you can actually present the data and retrieve the data depending on your needs. The only limitation you have here is the language. The T-SQL is going to be your limitation. So, for example, if you have any kind of experience with the graph database, there are some limitations. It's not because, the graph database has a limitation, but limitations because of the T-SQL or the features of SQL Server. You are still using the relational database at the end. So, depending what you are trying to do, SQL Server can be a NoSQL database depending on your needs. In Azure Cosmos DB, we are not really stuck with only one language like SQL Server. So as you can see, all of these are supported in Cosmos DB, and each of them is actually using their native language. So there's not really like a limitation here anymore, because its own limitation is the language limitation here. So you have one database service with many different data models with their own native database languages, so which is kind of great with the Azure Cosmos DB. Next one is indexes. Indexes are very important. Doesn't matter what type of database it is. In SQL Server, we have all type of indexes out there. The main one, though, mostly is the cluster, non-clustered, filter, unique. Those are probably the most common ones I can really think of in SQL Server. When we look at the Cosmos DB, we have two types of indexes, which is kind of equal to those indexes, which is the range indexes and the composite indexes. There's column store for analyzing data in SQL Server. There's the analytical storage in Cosmos DB, kind of equal to what column store does. Full text has been out there for SQL Server for a long time, and the full text actually indexes just introduced this or last year with all that AI stuff to the Cosmos DB. Before that, we used to use like Azure Search before that, but now full text indexes are available in Cosmos DB. SQL Server supports the geospatial data, and Cosmos DB actually does that too with special type of indexes to use. So the biggest differences here between these two systems are whenever you actually create a table in SQL Server, well, if you haven't, put any indexes on your create statement, you end up with no indexes. So you start with 0 indexes. In Cosmos DB, well, by default, it actually indexes everything. So if you have 20 columns or 20 properties, everything is indexed. That's one of the reasons, Cosmos DB says that they are very developer friendly, because developer doesn't need to worry about which needs to get indexed, how it's going to get indexed. Well, everything is indexed in Cosmos DB. So in SQL Server, you kind of need to figure out what needs to get indexed and add them one by one. In Cosmos DB, you kind of go the different way. You're going to figure out, okay, everything is indexed. Do I really need these indexes? Probably not. Then you're going to actually start to exclude those indexes so it will not go and index everything. At the end, the same idea, but tackling is totally different in the Cosmos DB and SQL Server. So indexes are centralized with the database. So indexes are in where the database is. Cosmos DB, that is the case, but you might have like 20 different servers. That means you have 20 different indexes in different locations. So the reindexing can be a challenge in Cosmos DB because it's going to take much longer, because rather than you are just indexing one file here in SQL Server, well, if you're going to change only one index Cosmos DB, you are going to reindex X number of indexes depending how many physical partitions you have. Because of that, in Cosmos DB, if you need to do any kind of index changes, you want to do all of them together. So the reindexing can be done, like much faster because it needs to index many more in databases potential, depending how much you have in the Cosmos DB. Also, reindexing in Cosmos DB is free, but not really. So you are gonna, like whenever you set up your Cosmos DB, you are gonna say, okay, I need let's say we need 1,000 request units, and that should be enough for the web application. Maybe web applications using somewhere like between 700 and 800 request units per second, then you have like 200-300 left every second. Cosmos DB actually is gonna use whatever left out there to complete the reindexing. That's one of the reasons that reindexing can be, can take a long time, especially if you have data, because it's just using whatever's really left, whatever you are not using to complete the reindexing. You can easily, scale up until the reindexing is completed, and you can scale down. That's an option. But that's something to kind of know, especially if you have a large data. Reindexing can take longer if you don't kind of scale up and make it, work faster. All right, and next one is store procedures. Store procedures are very important in SQL Server. They make things much more cleaner and faster. So they are really just SQL statements. And they are good for reading data or writing data. They give you better performance because SQL Server actually caches the plan, and it knows exactly what to do out there. So it gives you usually better performances. And you can join tables in SQL Server, so it doesn't matter if you can do things with the different tables. You can select different tables with the databases in the same server. You might even join the different databases potentially. So there's no problem with that in store procedures. In Cosmos DB, well, first of all, you must know JavaScript because all the store procedures are in JavaScript in Cosmos DB. They are write-friendly. They are not really read-friendly. They can read data, but it's really not recommended to read data with store procedures in Cosmos DB. The main reason for that is, if you remember the replica set, I share with you, it kind of looks like that. So we have a leader, we have 3 followers. all the store procedures in Cosmos DB will always get executed on the leader. They will not get executed on the followers, which means, well, our reader, the leader is busy with writing data, changing data, deleting data. The last thing we want leader to do is reading data. That's why, it's not really suggested to kind of create store procedures which actually reads data. Writing data will be perfect for that. And whenever if you're going to try to any kind of store procedure, try to keep them just write data, not read data. Each store procedures are specific to a container. So that means there's no joins in NoSQL databases. So whatever you can do in that store procedure, it has to be only for the container that you created for. You can easily implement actually transactions in store procedures because if you have any kind of experience with JavaScript, if something doesn't go wrong with JavaScript, it will just fail immediately. Well, that's how the transaction is supposed to be anyway, so you can easily catch that problem and just roll things back if you have to. So you can use transactions with that. Next one is the triggers. In SQL Server, those are special store procedures. We have 3 types of triggers in SQL: DML, VDL, and trigger, the logon triggers. So, and they get executed automatically. You don't really have to do anything. In Cosmos DB, again, these are special store procedures, which means they're in JavaScript. There are 2 types of triggers: pre-trigger and post-trigger. Pre-trigger actually occurs before you change anything in the the database, and post-triggers actually happens after something is done in the database. So you can easily use them to validating data or be sure that everything changed the way that you think or we believe is going to get changed. The biggest difference, rather than, I guess, the JavaScript here, is these triggers in Cosmos DB is actually get executed manually. So you have to, trigger them by using the SDK. They will not get executed automatically like SQL Server. Next one is computed columns. Computed columns can be really useful in SQL Server. Those are virtual columns. You can easily make them real column by indexing them. And well, all of these computed columns are available when you say select all from a table. You will see those computed columns in the results in SQL Server. And all those are indexable. In Azure Cosmos DB, again, these are the virtual properties. One of the biggest, I guess, differences is they will not be visible in select all statement. So you need to know them by your heart to use them. Most of them, you're going to use them probably like in the web clause. The only way to kind of know if they exist, you have to go and look at the SDK and write a line of code to figure out if there's any computed columns on it. Or you can go to Azure Portal, and there's actually out there computed columns out there. You can go and see if there's any. These are indexable, and computed columns usually, help you with the Cosmos DB builds. In Cosmos DB, everything is case sensitive, so you might need to use like lower or upper functions in your where class, so you can kind of tackle those case sensitive problems. Well. Again, this is a database. If you want to use a function in where clause, that's going to cost you. So you can easily create a computed column with this lower and upper, and actually can help you to save some request units or money for your queries. So computed columns can be very useful for that. Next one is pricing. Well, for SQL Server licensing, I guess we can talk about it all day. This is just like, it's going to compare here. There's many ways to actually pay for SQL Server. In Cosmos DB, things are a little bit more, I guess, simple. So first of all, you pay for CPU and storage separately. The easiest one we can explain is the storage. So for each 1 gig of data transactionally, it's going to cost you 25 cents per month. It's not really that much. When it comes to the CPU, there are 2 different ways you can pick. If you pick, for example, the serverless, you really just pay for what you use. That's a great option for dev environment, QA environment. If you are testing any kind of proof of concept, serverless should be the way to go for sure. Or the other one is this provision threshold that actually takes at least the minimum 400 requests per second. But for every 100 requests, it's going to cost you like somewhere like $6. So depending how much you are going to need, you can easily add and remove, those numbers, and depending how much you add for, that's how much Azure Cosmos DB is going to actually bill you for that. There's another one here, which is option for the provision. So if you are not exactly sure, or if you don't want to kind of scale up and down manually, you can easily pick an auto scale for the Cosmos DB. For that one, you are saying what is the maximum number you are willing to pay to Cosmos DB. Let's say, okay, maybe we want to go scale up as much as 4,000 request units. So actually, Cosmos DB will increase it, the scale up the database engine up to 4,000 if it needs it. If it doesn't, it will scale down automatically too. So that kind of gives you a little bit more, I guess, peace if things will kind of go, and if there's going to be a sales day, for example, tomorrow, it can actually handle those things automatically if you will program it that way. This one is views. So views in SQL Server, again, they're very nice to have, especially if you don't want to get a lot of data model questions from people. You can just create a view for them and they can just use that view. So you don't need to figure out or tell people how they should join the tables and which one should be the primary key, which one will be the foreign key. So it's really kind of useful views to tackle those problems. You can also like index them and they can get materialized in SQL Server easily. In Cosmos DB, the view concept is really not officially there. So you kind of, if you want something like that, you kind of need to create that manually yourself. You can use the change feed feature for that, which is equal to CDC in the SQL Server. So if something changes, you can easily take that data and replicate it somewhere else, and you're almost like duplicating the data, but you're kind of creating a view in Cosmos DB. Also, this year, I think it's still in preview right now, we have the global secondary indexes, which really kind of has the same idea of views of SQL Server. So what actually happens here is, by doing that, you actually create a new container, and you give a different partition key or different scaling information. It has its own kind of features out there you can control, and depending on the query, you can use a global secondary index container, or you can use the regular container, depending if you have, for example, the partition key or not. So this can really, I guess, tackle all kind of cross-partition problems you might have. If we look at that in a bit more details here. So this is the change feed. So let's say this is the cross-partitioning problem many people might have with Azure Cosmos DB. So we have a container named orders. Our partition key is customer ID. But maybe one of the projects came up with a different idea, and our select statement now needs the product ID. We want to see all the orders for this product. Maybe that's the warehouse. We create this application, and warehouse wants to see all the orders per product. Well, it doesn't really work for the backend because, as you can see, we don't have the customer ID anymore, and we need to send this query to every database engine we have, and each of them is going to bill us, either they return data or not. So we are in trouble because, as you can see, it costs right now 49 request units, and this is going to get even uglier later because probably you are going to have more data, which means that you're going to have more database engines. So if you don't tackle this problem, it's going to get even worse later as your data grows. So what do we do in this situation? Right. Currently, we are just wasting a lot of money here for no good reason. We can easily use the change feed function as I explained here. So we are going to go and create a new container, orders under product, or you can call it whatever you like. So we have that CDC information or the function called change feed in Azure Cosmos DB. Data change is going to come. We are going to save it here as partition key customer ID. Then CDC is going to actually trigger or the change feed is going to trigger an Azure function, which you need to develop. And in this case, this is going to actually pass all the information about what changed. So you can take that information and sync that data to the other duplication, duplicate the data to a different container. And you are going to get charged here for the insert charge because we are really doing another insert here. So by doing that, what we did is, okay, if we have the product ID in the where clause, I go get the data from the orders product. If I have the customer ID, then I get the data from the orders. So that's really the easiest way to tackle this problem. Because at the end in cloud, storage is the cheapest, the service you get. And if you can fix that by using the storage, then usually this is the way to go. Now, I explain you global secondary indexes, which is going to make this process much easier because, as I said before, you are responsible to, configure the change feed and write the Azure function and sync the data. So this part is really your responsibility. If something fails, you kind of need to figure out and fix it. In global secondary indexes, they actually made that process much easier. So this is the same idea. What you are going to do right now is, let's say we have the container name orders. You are going to actually go and click on the orders, and you're going to say that you want a new global secondary indexes. What is actually going to do is it's going to create a new container just like the other way, but you are going to have control what needs to go in the new container manually. There's going to be a setting for that. You are going to actually call, if you are not going to use this container that much, you can control how much you actually spend on it by, saying, okay, I want maybe 400 request units for that because I want one warehouse and I have 10 people working out there for using this application. So I don't need to, have a huge container with a big number to, the threshold for that. So this is, that's how it's going to work. So what's actually going to work here is the data is going to come to the orders container, just like the other one. But as you can see, all that Azure functions, all that change fit is not here anymore. Cosmos DB is going to actually handle that for you. And this is going to be actually free. The other one, you were actually, getting charged for every insert or update. In here, all that kind of CPU work, syncing data to this new container is actually free. And Azure Cosmos DB handles that for you. So you don't need to write a code. And this is very easy to set up. And as I said before, this GSI container has its own kind of storage and RU limits. So you can easily, orders might be pretty, maybe heavy. You might need like 5,000, 6,000 request units for that. But this one, you can easily say that, okay, I don't need that much power here. 500, 600 might be just fine for this one, depending on your usage. So you can easily control that. So by doing that, as I explained, you now, rather than searching the data in the orders container, I'm searching in the orders under product because I have the product in my where clause. Rather than calling every database engine we have, now I have the product ID, that is the partition key, and it cost me 8 request units rather than 49, which means that, the business is going to be happy because now we are not wasting our money and RU to fix a problem like that. Next one is tuning. So tuning is a whole big thing in SQL Server. Many people there are a lot of conferences just for tuning. So it's very important to kind of watch a couple of important things in SQL Server when you are querying data. The first one is, which kind of probably applies to every database out there, you want to select only what you need. The idea is, very simple. You might have 100 columns. Maybe you need only 2 or 3 of them. By just writing select all, well, the package comes in and out from the SQL Server is going to get larger because it gives you everything, and that, makes things slower. You might want to watch for the missing indexes. Probably that's the fastest way to kind of fix problems in SQL Server. Those you can easily kind of figure those from the execution plans, or if you know exactly where to look at, it's pretty easy to kind of look at the queries and see what index is available in SQL Server and see if you need any indexes there. You want to be careful with the query hints in SQL Server. Those are the hints that you are actually telling SQL Server how it should do its job. Well, in some cases, rarely it might work, but in long term, it usually fails as your data get changed, structures get changed, data get larger. Those query hints can get, invalidated quickly. So be very careful when you are using them in SQL Server. There's parameter sniffing problems in SQL Server. Usually it happens in the store procedures. So those might be, not easy to catch sometimes, but you might need to, watch for those. Whenever you can use the execution plan, and that will give you exactly, where the data is usually. There might be a lot of icons out there, a lot of information, but I guess that's one of the best part of the SQL Server. It really tells you what's actually happening in the backend, so you can see and tackle the problems by using the execution plans. If indexes are not enough, as I said before, you can use the partitioning to make the your queries faster for if your data is getting much larger. In Cosmos DB, again, it's a database. That means that you want to select what you want to select rather than using select all. Same with the SQL Server. You can easily use the indexing metrics of Cosmos DB to see if you're missing any indexes. You can easily do that on the portal, Azure portal, and the SDK. It can suggest your indexes. Just like SQL Server, though, just because it's suggesting, it doesn't mean that it's going to work. You want to kind of test that in dev before you put it in production. Cosmos DB has point read feature, which is available only from the SDK. That is probably the fastest way and cheapest way you can get data from Cosmos DB. When the point read happens, that means that Cosmos DB does not need a query plan. That's one of the, I guess, how you save some requests when you save money with that. For it to work, you are going to need to pass the partition key and the ID of the document. So as long as you have those two IDs, you can actually execute and point read and make your query much faster. Point read can read only one document, though. So, you cannot really return many documents with that. So if you know exactly which document you are looking for, as long as you have the partition key and the document ID, you can easily execute the point read. That's why it's important whenever you are, creating your applications, application, you want to be sure that, partition key and document ID is always available. When they click on, for example, if you have a list and a grid, and somebody clicks on the grid, if that document ID and partition key is available, you can easily, make your Cosmos DB really affordable by doing that. In SQL Server, everything is normalized. So it's normal to have 10, 15, 20 tables for a data model. That's not how Cosmos DB works at all. So you want to actually minimize the number of containers in Cosmos DB. The last thing you want to do in Cosmos DB is, for example, if you are moving from SQL Server to Cosmos DB, take the data model as it is and put it in the Cosmos DB. That was the biggest mistake you can make because things will be very expensive if you are going to go that way in NoSQL. We talk about the cross-partition queries. If you are having an issue, not all the time you can find the perfect partition key. You're always going to have some cases that you don't have the partition key. You can easily tackle those with the materialized views. Cosmos DB has this TTL option, which is really useful. It's time to leave function. So if you have any kind of retention policy, let's say after 3 years, you don't care about the data anymore in the operational database, then you can easily say the TTL is 3 years, and Cosmos DB will start deleting the data after 3 years automatically. At the end, in the Cosmos DB, just like an operational database, you just want to keep the hot data out there. The data, you don't need it anymore, just move it somewhere else to keep things working more stable. We have the execution metrics, just like the execution plan, but you really cannot compare the details. It gives you a lot of kind of information in kind of milliseconds, how long it takes, but it really doesn't give you that much like information like execution plan. They can be useful depending what you are trying to do, but don't expect details like the execution plan in SQL Server.
There's about 8 minutes left.
All right, thank you. All right, the next one is the null and undefined. So you kind of need to be careful whenever you are, using any kind of null in SQL Server. Null is really not equal to null. If you look at the where clause, you want to use the is null and is not null for nullable in SQL Server, and be careful whenever you are using any kind of aggregation, because in some cases it will not count the null, and numbers might be different than what you expect. Same in the Cosmos DB. The biggest difference is, well, we don't have a schema. So if there's a null, you need to keep the field in your data model. So for example, date of birth is one of the optional option, and you don't have the date of birth, just don't keep it in data model. You don't have to have in Cosmos DB since there's no schema. So that's probably the biggest difference between the SQL and NoSQL here. Just don't keep the null values in database in NoSQL in the Cosmos DB. When it comes to the data modeling in SQL Server, as I said before, everything is normalized. It's really working like a place. You go and you tell exactly what you want, and SQL Server join tables and give that to you. That actually puts a lot of constant pressure on the query optimizer. But that's how it works, and that's where the flexible it is. In Cosmos DB, things working a bit different here because, well, you better know what your actual customer wants from you, because we don't want them to come to the shop and wonder which sandwich they should pick. We want them to come here, they know exactly what they want, and leave. So if your customers are, for example, vegetarian, well, you put a lot of vegetarian make ready, and they come and just pick up what they need and leave. So that's the best way I guess I can explain the data modeling between two database engines. There's no joins in Cosmos DB, and as I said before, you better know what the service or the web application wants from the Cosmos DB before you start to write the data model. So which one should I use? That was the question we were going to answer. As you see, there's a lot of information here. Don't just pick the SQL Server because it's just relational database. SQL Server has many other functions here, and it can be a JSON. It can be a NoSQL database if you are writing a small application for enterprise, for example. You don't really need to pick a NoSQL database for that. Just be sure that you know that there's a limited scaling depending on your project. That's something to consider. What is great about SQL Server is it's available on-prem, so it doesn't have to be on cloud, and it's aggregation friendly. When it comes to you can use a SQL Server as a data warehouse or operational database. So that's kind of great with the SQL Server. For the Cosmos DB, you just don't pick it because it's not a relational database, because actually it's supposed to PostgreSQL. So it's relational and non-relational database, really. It has a high scalability. So if you are creating something really like a big different regions, different countries, that may be the way to go. If your application is already on cloud, well, Cosmos DB is already there. So that might be a way to go for that too. And Cosmos DB gives you multiple consistency levels and global distribution. So if your application is much bigger, Cosmos DB might be the way to go. So how do I start? In SQL Server, there's all kind of options. You can just install your computer and start from there. Cosmos DB, well, you don't really need subscription to start because there's Cosmos DB emulator. You can actually save it on your computer and it will work from your computer, and you can learn it without needing any kind of subscription for the Cosmos DB. Cosmos DB has the serverless and also the free tier option. If you are going to go live, be sure that you are using the free tier for the Cosmos DB. Well, I did it. That's the last session. And as I said before, if you will have any questions, I'll be more than happy to answer them now, or you can ask me later from any of those social media. Thank you.
Wonderful presentation. I really like some of your analogies. If there's anybody has any questions, you could please type them into the chat and they'll be answered. So I think everybody is very appreciative and thought it was very informative.
Thank you. Thank you very much for coming to my session. And as I said before, if you have any questions, I'll be more than happy to answer any of those social media later.
One suggestion was it'd be good if there's one real life case study could be presented, but in general, everybody's saying it was a fantastic session. So thank you again, Hasan, for your time. We appreciate it. This is being recorded and will be posted before the end of the week up on our YouTube channel. Thank you again for attending.
Yep. Thank you, everyone.